Today we're going to discuss observability into your containerized workloads with AWS and Logz.io. But first I'll cover a couple of housekeeping items. So first off, please feel free to ask any questions in the chat box. We're going to leave some time at the end to get those answered by our speakers. And next, just know that this will all be recorded. So if you miss anything, you'll be able to check out the recording, which we'll email to you within the day. So now I'd like to introduce our speakers. We're lucky enough to have Vipin Mohan today, who's the principal segment lead for containers in AWS. Hello, Vipin, and Dotan, if you could just give us a next slide here. And also joining Vipin, we have Dotan Horovits, our product evangelist, who is plugged into everything open source observability. So Vipin and Dotan, thanks so much for joining. We're excited to have you both today. So next slide, please, Dotan. Next, I'll cover the agenda. So we'll start off with the state of container adoption and follow that up with the challenges of monitoring containerized environments. And next, we'll cover why cloud native monitoring requires observability, and we'll explain the roles of logs, metrics, and tracing data to achieve that. Then next, we'll discover the role of open source standards and open source tools in observability. And lastly, get into the AWS and Logz.io integration. So to kick things off, let's get started with a quick poll, which I will launch now. All right, here we are. So I'll give you all a few moments to answer the question: what percentage of your applications are containerized? And so just give you all quick moments here. Just give your best estimate if you don't know exactly, and then I'll share the results here with everyone. Looks like we're at 65% voted. Anyone else? All right, I think answers are starting to slow down here, so I'll close the poll unless there are any more final answers. All right, and now I'll share the results. Looks like most are at 50 to 75%, so 50 to 100% of applications containerized majority of the answers here. All right, so with that, we'll transition into Vipin's first couple of slides here about the state of container adoption. Vipin, take it away.
Awesome, thank you, Charlie, and great to meet everybody, and super excited to be here on the webinar today. It is interesting to see the results of that poll, and if you see what you're seeing on this slide right now, there was a DevOps Pulse survey last year in which Logz.io played a key role, and the results aren't very surprising. If you think about it, about half of the respondents have said that more than 50% of their apps are containerized, and a significant portion, almost a third of their apps are they're already containerized. So, and the other interesting aspect over here is that respondents are from a wide array of companies of different sizes, all the way from startups to enterprises. And it could be a small startup with like 1 to 10 people, or anywhere over like 1,000 employees. And this trend seems to be consistent across all different types of segments and industries and verticals. Dotan, do you want to go to the next slide, please? Awesome. So if you think about it, containers are becoming critical to a lot of businesses. And that's because companies are increasingly global these days, and products are becoming a lot digital. So you have an app for almost everything. And with cloud, mobile, and big data and social technologies, there's been so much impact to application development. But the digital disruptions are forcing change even faster than that pace. So what this means is that the new normal for application developers should be to splice the digital DNA into their culture, processes, and technologies to transform the entire organization itself. And with that, there's a rapid innovation need that comes. In the last couple of years, we at AWS have seen a huge growth in the adoption of containers for production use cases. And as you can see in this slide, a CNCF survey showed that 65% of organizations choose to run their containers on the AWS cloud. It's also interesting that Kubernetes, that you probably heard about a lot, is an open source software, and Amazon EKS runs the upstream version of Kubernetes. So there's no forking of the upstream version. And the idea behind doing that is that customers can use all of the existing plugins as well as tooling from the open source Kubernetes community. And as a result of that, the role of open source becomes very critical, especially around like container runtime, where you have Docker, or there's orchestration, there's monitoring, there's a security which is becoming very, very critical. So Dotan, do you want to like share some thoughts on the role of open source, and what your perspective is on that?
Yes, that's actually a very good point. First of all, very exciting to see these figures and how much of an adoption actually of people running their containers on AWS, and also AWS's involvement in open source, because open source is, as you said, a key in this specific domain of containers and cloud native in general. And it's all across the board. Again, as you said, the Docker itself being the container runtime, which essentially popularized the notion of containers in the industry, and then Kubernetes, which is today the de facto standard. The CNCF, the Cloud Native Computing Foundation, plays a key role here, both as the house for Kubernetes, built around Kubernetes, and then Prometheus joining the second project to graduate, and then by now many other projects. But it's not just the tools, it's also the standards, the importance of providing vendor agnostic, unified standards that can converge the industry. So you can see open telemetry for a way of collecting all sorts of telemetry types, metrics, logs, traces. You can see open metrics as a way of exposition format for various platforms to share their metrics. You can see, but really across the board. And if we talk specifically, so you have open source play around the runtime and the orchestration and management and security. But if you want to focus on monitoring specifically, then we can see that all the observability stack today is, by far led by open sources. So we mentioned Prometheus, the second project to have graduated the CNCF, is today the de facto standard for metrics. We see Jaeger tracing for distributed tracing. Under the CNCF, there's the ELK stack. Actually, this is a bit of a different animal. It's not under the CNCF. It's governed by Elastic company. And maybe an interesting anecdote from earlier this year is that Elastic decided to relicense Elasticsearch and Kibana, which obviously makes it changes the open source landscape around that. And then alternatives are emerging. One of them very interesting that AWS is involved in and leading is OpenSearch, which is essentially a fork of Elasticsearch and Kibana that provides an Apache 2 successor or next generation for continuation, community-led continuation for Elasticsearch and Kibana. So it's a very active open source community around observability. With these pillars, Prometheus for monitoring, Jaeger for tracing, the ELK stack for log analytics, that definitely lead the way around that. And another interesting thing, we saw the data. We saw that both on the poll people answered, and also on the survey, that everyone is moving to containers. But then again, when you ask the DevOps people, when you ask the practitioners about how it actually is done in production, you find out that still many of them don't know how to run them, how to do it right, how to do it simple and production ready, most importantly. So and this is again a question that was asked in the community, and the number one issue that was raised around monitoring or running Kubernetes in production was monitoring and troubleshooting. That's definitely 44%. But then again, people report issues around security, around networking, around cluster management, and you name it. So it's definitely not in the place where it's smooth sail with the open source, which, by the way, explains why you see many turning to cloud solutions, to managed solutions such as AWS and Logz.io to offload some of this headache, which can very much explain the popularity that we've seen with AWS. And also beyond managing and installing and managing and upgrades, there's also all the let's call it wrapping around the open source that is missing in the core open source, like taking care of compliance and role-based access and managing multiple teams and multiple accounts and other enterprise-grade capabilities that are typically not part of a standard open source project. So I think that relates very much to what you showed, Vipin, about the popularity of the managed Kubernetes and managed containers. And as we said, the number one issue is monitoring and troubleshooting by far. The answer that the open source community brought to that is observability. Essentially, cloud native monitoring requires observability, and I would say even more than that. It's not just that it requires that, it's part of the very definition of cloud native systems. If you look at the definition here by CNCF, it talks about systems that are resilient, manageable, and observable. So it's a quality of cloud native systems, and it's very important to understand. But what is observability anyway? So if we go to the formal definition taken from control theory, it talks about a measure of how well we can understand the internal states of the system by knowing external outputs. And what are these external outputs when you talk about software systems? That's obviously the telemetry that our systems emit, namely the metrics, the logs, and the traces, what's known as the three pillars of observability, where typically you can think about it as metrics tell us the what happened, help us detect that something got broken, some endpoint suddenly stopped responding or is very slow to respond or something similar. Traces can help us understand where exactly in our very highly distributed microservice architecture things got broken or bottlenecks or got a high latency. And logs can tell us why these things happen. So this is how all the telemetry comes together to help us investigate incidents and understand our system. So if I go back to observability and try to put it in plain English for software systems, you can think about it as observability as the capability to allow a human to ask and answer questions about the system based on the telemetry data. And the reason I like this definition much more is that it makes it very clear what to expect out of observability. The more questions we can ask and answer about the system, the more observable it is, which essentially means that observability is a data analysis problem. And this is the right way to think about that. This is also a very good guide to how to set up an effective observability in your containerized workloads and in your environment in general. Because many, for example, come to face, even if they have all the telemetry, the metrics, the traces, the logs, they still have them in data silos. And then this creates broken troubleshooting workflows, let alone that they need to now manage a lot of tools. But as we said, data analysis problems means that we need to have one data lake, everything fused into one place where we can ask questions, correlate between the different telemetry, and get the overall picture of what our system does and which state it is. So that's about it, and maybe we can go to the next poll.
Yes, sounds good. Thank you, Dotan. I'll launch the next poll here. All right, next one's going to be, how many different tools do you use for monitoring and observability of your system? And so So like last time, I'll give you all around 30 seconds to join, to answer, and we'll review the results. And in the meantime, Dotan, if you care to join us on webcam, we'd love to see you.
Oh, of course.
But I've gotten lost there in a moment.
Apologies for that. I thought that I had that on. Apologies. Can you see me now?
I think we have to wait till the poll is done, and then I'll let you know.
Okay. Thank you for letting me know.
All right, we're at 75% voted, 76. Any more stragglers before we close it here? 76, I'll take it. So I'll share the results now. Looks like one's using 0. Most are in the 1 to 4 range. So it looks like everybody's in the right place today. All right, thanks. I'll hand it back off.
Thank you very much. And as we said, I think it's a very clear read about what we said. 57% with 3 or more tools speaks it. The tool sprawl is one of the I guess the issues with the current environments, and people are facing this. One of the challenges. By the way, also the CNCF technology radar reports very similarly. Some people talked about even 10 or more. So that's definitely one of the current challenges of the industry around observability. And that's in fact where we as Logz.io, this is a challenge that we take upon ourselves. We offer a cloud-native observability platform that offer you a way to send your logs, your metrics, your traces into one centralized managed place for indexing, for storage, for visualization. And the nice thing is that it's all based on these best-of-breed open source monitoring tools that we saw before, Elasticsearch and Kibana and Prometheus and Jaeger and so on, but without the hassle of managing them. And but more importantly, as you remember, it's a data analytics issue. Then having everything unified on a single platform, easy correlation, and with additional features for troubleshooting. So I would like to have a very quick, maybe show you what we talk about instead of the slideware. So let me switch here over to sharing this my screen with you. Just a second. Let me show that. Oh, sorry about that. Where is my desktop? So okay, let me see, just making sure that no, it doesn't share the right screen. Just apologies for that. I'm doing it again. Show.
Yep.
Okay. Now,
awesome.
Sorry about that. So what we can see here is essentially a Logz.io platform, and here we're in the metrics tab, as you can see, and you can see here a typical dashboard. On this dashboard, you can see your Kubernetes cluster in this example. By the way, there are lots of pre-made dashboards for different AWS services, so SNS, SQS, Redshift, and so on. So lots of pre-made content that can save you a lot of time. This one is specifically about Kubernetes. And you can see here, for example, the number of running containers, waiting, terminated containers, running pods, waiting pods, pod CPU usage, memory usage, a lot of information that's relevant here. And this gives you, as we said, metrics tells us the what happened, and what's the state of the system. That's a good starting point. Specifically here, for example, we can see something that is maybe interesting to look at, which is a rise in the pod memory usage. So you can see here suddenly something rises even beyond the threshold that is defined here. You see the red line on 500 megabytes, but here it reached even over 1.5 gigabytes, which is quite interesting. This is as you can see, the Nginx, an Nginx pod. let's zoom in here, clean it. You can see it's an Nginx pod, and definitely indication that something wasn't as normal here. If I correlate it with another metric like the pod CPU usage, I can see a spike in the pod CPU usage. Again, under the same Nginx, 25% of the CPU usage was attributed to Nginx. So it seems that something was wrong with this pod. And then when I understand that something was wrong, that's the what part, now I want to start the investigation. I want to start understanding why things happened. So firstly, we can already start correlation from within the screen. So I can have a look here, for instance. You see these red lines, these are the vertical lines, sorry, these are markers that tell us correlate the metric with data from the logs about our CI/CD. For instance, here, I can see a Kubernetes configuration that was changed shortly before this started spiking. So from the CI/CD pipeline, I can get an indication on the timeline that says, okay, something might have been related to that new drop, that new release, that new deployment. And then I can see another marker, and I can see, let's see, fail to auto-terminate pod. So again, it seems to make a lot of sense with what we see here with the spike. So I can get a lot of useful information and correlation already here within the metrics dashboard. If I want to delve further in and understand why things happened, I can then correlate with the raw logs themselves. Now, thanks to the fact that I'm on a single unified platform, I can actually correlate that with a single click. I can click here and explore in Kibana, and then the entire context of my search transitions from the metrics to the log. So you can see here, let's scroll up, the same time frame that I was looking at, the same search criteria, the cluster, the namespace, the Nginx service, the pod name, everything is already set. So instead of looking at millions of logs, I look at only 3.5 thousand. And now I can start sifting through the raw logs and try and understand what's been going on in the system, like you typically would with Kibana or with any other log analytics system. The thing that we've added on top of the open source here is machine learning that sits on top of the ingestion pipelines, analyzes all of the incoming logs, and then identifies patterns that emerge out of these logs. In this case, identifying common exception patterns, and then aggregates them into the common pattern. So what you see here, for example, the IO exception is not just IO exception, it's a cluster of all the similar IO exceptions on the same service, on the same path, the same stack trace, if you'd like, and aggregated under one line. We can see that on the started spiking around the same time frame. So it seems to correlate also the exception with what we've seen before with the metrics. So it makes a lot of sense. And if I look into the log specifics, the exception specifics, I can see that it's on the Nginx log, and I can see it's an IO exception with too many open files. So this already zooms me into the place where I would now want to go and look at the configuration, might be also in the source code to start to root cause the issue. So that was very short demo, but just to give you a sense of what it involves in correlating different metrics under one unified observability and the data analytics flow that can accelerate significantly the way that you root cause and you get to the shorten the mean time to identification of the issues. So let me just go back to the slides. No, that's not the slides. Here we go. Let's see that we can see that on your screens as well. I'll just put it on full screen.
Yeah, I can see it, Dotan.
Yes, great. And now let's move on. Doesn't seem to be, sorry. Okay, now, sorry about that, present. And now, one last note about that is if you run on AWS, then it's very important that this platform runs on various AWS regions. So obviously, both from conformance, GDPR, or otherwise that you need it locally, or from latency perspectives or efficiency, you have the data stored on your region of choice across the board. And with that, it would be interesting, Vipin, to get your take on how AWS enables this observability, and also maybe some challenges that your users encounter around implementing observability.
Yeah, absolutely, Dotan. So I must say, I love that demo, and my favorite part in that was how you're able to preserve the context across different views. And as an application developer, or as an operations person, that's super important, because if you have that context, it gives you the full picture of what's going on, and you're able to like root cause quickly. That's something that you brought out as well. So that is an awesome demo. And thinking about observability and monitoring, within AWS, we see customers using observability for 4 main use cases. The first one is infrastructure monitoring and observability. So infrastructure includes things like virtual machines, containers, operating systems, all of that. And they are, a super important part of the puzzle when you have applications running in the cloud and in containers. Things like resource utilization by services within a container cluster, or your application and system logs are really important, and remain a critical part of your observability strategy. The second use case is around AWS services. So many of our AWS services automatically publish metrics and logs to Amazon CloudWatch. And the more services you use, the more important it is for you to have the context about what's happening, and have all of your logs and metrics collected in a central place. So with many AWS services, you're abstracted away from the management of the underlying infrastructure. And CloudWatch and monitoring enabled through CloudWatch is super important, so that you can have a full picture in a one-stop shop. The third use case is around application performance. So building upon infrastructure in AWS services, customers are running a lot of their applications as containers. So understanding, how those applications are performing, what is the latency like, what is the performance of those applications is super important, because it ultimately determines what your end customers are seeing, and what experience they are having from your applications. And this is also where tracing and code profiling come into picture. The last use case is around like end user observability. So here it is about like figuring out what your end user is experiencing, and you get an outside in view with better observability into performance and availability, so that you become aware before things actually hit your end customer, and then you're able to quickly fix any issues, and make sure that your end customer does not have any impact in terms of any issues that they may encounter. Dotan, do you want to go on to the next slide? Yeah. So talking specifically about logging challenges with container workloads, if you think about it, you have multiple different data formats that you're typically dealing with container logs. You could be having plain text logs, or you could be getting logs in the form of like JSON outputs, or it could just be like log streams from Kinesis, or any kind of a streaming source. The second thing is around like multiple destinations. Increasingly, we are seeing that customers want to send these logs to different destinations for different purposes. It could be that you want to send logs and metrics over for visualization, or it could be that you want to send it over to a place for analysis. Another new use case that we're seeing is people use monitoring and logging for a security purpose. Sending it to a machine learning destination, wherein it can identify any anomalies and alert you if there's something that's not supposed to be happening. In addition to this, especially with open source ecosystems, there is a wide variety of third-party and open source tools. We saw some that Dotan covered earlier on in the presentation, and also there's like MongoDB, GraphDB, a variety of open source tools, all of which customers use along with their container workloads. That's some of the challenges. What's also important is collecting data is hard. So you have a ton of logs coming out from your container workloads, but not all of them are of equal importance. For example, some may require real-time analytics. Some may need to be just stored for long-term compliance. We hear that a lot from our healthcare customers, because they just need to store data and logs for HIPAA compliance, for example. So there's like different reasons, and collecting data becomes really hard. And lastly, if you think about it specifically from a Kubernetes perspective, placement is a challenge. So even though you can potentially target nodes with things like node affinity, or like use label selectors, eventually it's all up to the Kubernetes scheduler about which pod gets placed on which node. Dotan, do you want to go on to the next slide? So this is where we have been leveraging some open source software. FluentD and FluentBit are a couple of them. There's also OpenTelemetry, which we'll talk about later. So FluentD and FluentBit are open source data collectors, and they're also like routing tools. So think of these tools as a routing center wherein you send logs from like different formats, different sources, and these can actually aggregate data from multiple sources and multiple formats and spit out a unified JSON object. So that way it becomes easier for your consumers or the destinations because they can now expect a standard JSON format output log. And there's FluentD and FluentBit are sister projects. FluentBit is much more performant. It's written in C, and I think both of these have been like great projects. And we have something called AWS FireLens, on which we're working very closely with Logz.io to build an integration around. So that's my perspective. Dotan, do you want to share anything else that you see in terms of challenges in observability?
Yeah, so I think you brought a very, very good point about the challenge of, any typical system these days incorporates so many third parties tools, whether it's open source projects like you mentioned, or cloud services like AWS's. Regardless, you need as a monitoring, you find yourselves, your web app and your API gateway and your message broker and your queue and whatever, and all of that is you didn't write it, but you still need to monitor that. And that brings a lot of, for example, here on the screen, you can see a typical data pipeline. And just imagine how many, or see here in front of you, how many pieces are involved in just a data pipeline. And that's just a data pipeline out of the entire system. So really, in terms of monitoring, it becomes a challenge because each monitoring system now needs to monitor a huge ecosystem. And by the way, it's a very dynamic ecosystem. It's very crazy as an engineer chasing this constant chase about the latest and greatest in the open source and in the cloud services. It becomes crazy. And so you need something that will support not only a very large ecosystem, but also a very dynamic ecosystem. So this is one of the challenges that you mentioned also in the context of FluentBit and FluentD and others that sort of do some partial aggregation across a multitude of them. But we look at it in a broader perspective at Logz.io, where it's an essential part of the platform, the framework, to let you send whichever data source or telemetry source that you have. So not just across logs, metrics, and traces, but also across the different frameworks, whether open source tools or cloud services, or even instrumenting your own source code, .NET, Java, Python, whatever. Make sure that you can send it from whichever format into one unified data store to aggregate, to store it all in one data lake, if you'd like. Ingesting it, parsing it, indexing it, storing it efficiently in different layers and different, as you said, the duration, because not all the logs, as you mentioned very nicely, not all the logs are the same priority or the same importance. So you can store different data on different hot tier or smart tier or a colder tier, or maybe even archive it to S3 and just fetch it upon demand. And as we said, also machine learning that upon ingestion can perform all sorts of insight analysis and provide all sorts of enrichment of the data, and exposes it via the different APIs, as we said, the different visualizations, the Kibana-wise, the Prometheus-wise, the Jaeger-wise, and so on. So it's very it's in the very core. Maybe you can actually look at the framework itself and see what I'm talking about. So just a second here, I'll share again. Where are we? Here we go. So what you can see here in front of you, essentially, that's again the Logz.io framework. And you can see if I look at the, for example, on the logs, and I go to the send your logs, I can see the different means of sending logs. And as you can see, we talked about FileBit and FluentD and FluentBit, and all of these, you can see them here as part of the framework. You can see here various, let's maybe zoom in, various AWS services. So you can, you mentioned before CloudWatch, or everything that CloudWatch aggregates from different AWS services, you can then forward to Logz.io. But then again, you can also fetch logs directly from individual services. In the context of containers, you have ECS, you have EKS, obviously you have Fargate. So these are in the context of containers, but generally speaking, it could be a S3 bucket logs or VPC or Kinesis or otherwise. Certainly also the CI/CD tools that you have in your pipeline, you can integrate with them. You can also have different packaging. You can have an image that you can install that provides the Docker container logs, or the FluentD to fetch the Kubernetes as a daemon set or as a Helm chart. So very, very flexible in terms of fetching, means of fetching your logs. And as we said, you can even do that from your own code, Node.js, Python, .NET, or others. That's on the logs. On the metric side, again, we talked about Prometheus. It could be also Telegraph. It could be various AWS services that you can see here. So it's really up to you whichever means that you would like to send your data to Logz.io, and then it's under one unified platform in which you can then choose the way. Let me just share again my screen. Then you can then decide how you want to investigate, to troubleshoot, to make the incident management, and how to expose that. So that's regarding that. And we mentioned OpenTelemetry before. I think that's very interesting. Out of all the open sources, again, lots of them. But one interesting point about is OpenTelemetry, because that seems to be the emerging standard across all the different pillars of observability: logs, metrics, and traces. And that comes to answer one basic question, which is, okay, we want to have one unified observability, which is fine. But then again, in practice, all of us know, then I need to have this API to work with my, I chose this tool for Jaeger for tracing, then I need to have this SDK for Jaeger. And if I have Prometheus, then I need this sort of instrumentation. If I have these logs, then I need this agent, a FileBit or file, whichever you work, and metric bit for metrics and so on. So how could I get unified observability without being tied into the backend tool that I use for analytics? And that's exactly the CNCF project that comes to address that. It provides one unified set of vendor-agnostic APIs and SDKs. So, for example, for Java, you have one API, one SDK across metrics, traces, and logs, and you can instrument based on that, and then send it to OpenTelemetry Collector. OpenTelemetry Collector collects from all over your environment, all the telemetry, can perform all sorts of aggregation, all sorts of post-processing, sampling of the data, enrichment, and so on, and then export it to any backend of your choice. So you still have the freedom to choose. You want to use Prometheus for your metrics, use Prometheus, send it, export it to Prometheus. You want to use Jaeger for tracing, or Logz.io or AWS or other, you can do that. So it's really agnostic about which choice of backend tool. It just takes care of the generation, emission, and collection of the telemetry, and then a unified way to expose it to any backend of your choice. So that's a very exciting project that gains a lot of attention, and I think it would be very interesting maybe hearing, because AWS has been significantly involved in OpenTelemetry, and maybe Vipin, you can tell us a bit about OpenDistro and about AWS's activity around OpenTelemetry.
Yeah, absolutely, Dotan. So AWS Distro for OpenTelemetry is a secure, production-ready, and AWS-supported distribution of the OpenTelemetry project. So open source is, increasingly being a key focus for us within AWS. And as part of the Cloud-Native Computing Foundation, OpenTelemetry, like you said, provides a lot of open source APIs, libraries, and agents to collect distributed traces and metrics for application monitoring. Now, with the AWS distro for OpenTelemetry, customers can instrument their applications just once and then send all the correlated metrics and traces to multiple destinations. Now that could be an AWS destination, or it could be a third-party destination like Logz.io. And using auto instrumentation agents to collect traces allows you to do that without actually changing your code. AWS distro for OpenTelemetry also collects a lot of metadata from your resources, whether you're running like container workloads or any kind of workloads on AWS, as well as any managed services, and you can correlate all of that application performance without the underlying infrastructure data, and that helps you isolate the problem and reduces the mean time to problem resolution. You can also use AWS distro for OpenTelemetry to instrument your applications running on containers specifically. Since that's been a topic of our talk today, it works seamlessly with EKS, with ECS, as well as with Fargate. And even if you're running Kubernetes on EC2, basically like without using a managed service, you can still use AWS distro for OpenTelemetry. Moreover, there's been an increasing ask from our customers to support hybrid workloads. So you're seeing, things like Amazon ECS Anywhere and Amazon EKS Anywhere that we're going to be, bringing to the market later this year. So both of them will also be compatible with AWS distro for OpenTelemetry. And a highlight that I want to bring to our audience today is that just a couple of weeks ago, I think end of April, AWS, as well as Logz.io jointly announced that the AWS distro for OpenTelemetry now has a Logz.io exporter, so that you can use that to collect traces and send that data over to your Logz.io endpoint. So, for us, the partnership with Logz.io has been super productive and extremely useful to help us serve our joint customers, and we have some exciting stuff planned for you later this year. So, looking forward to collaborating further with Logz.io and serving our joint customers. Dotan, you want to go on to the next slide?
Yes, that's really exciting. Thank you very much, Vipin. And I think it's really exciting to have these collaborations, and soon to have some more good news to share with our audience. So stay tuned with us to some more interesting bits that will make your lives even more smooth and smoother and easier. But maybe just to wrap up the point of where you can really get your observability in action in a very easy and intuitive way, because that's what we are all about in Logz.io. We are here to provide you guys, the users, you people, the users of AWS that run their workloads, a way for cloud native observability, having all these great open source that we talked about, Elasticsearch and Kibana and Prometheus and Jaeger and so on, as accessible as part of the platform in grinding within the platform, but you don't need to take care of the hassle of managing them at scale. And more importantly, even to me at least, is that it's unified on a single platform, because remember, observability is a data analytics issue. It's a data analytics challenge, and you need to take down the silos, have one place with all the data accessible to be able to ask and answer questions about your system and understand your system. So this is really the key, a unified set of all of your telemetry under one single pane of glass. And as I said, with additional features to troubleshoot faster. So you have the machine learning to monitor the ingestion and to flag all sorts of insights. You have all sorts of ways to easily correlate one information with the other, to collaborate on the things. Really an overall platform. And you have the link here below. Feel free to reach out and try out. You have a free trial, so you can just get your hands dirty and get the feel for it yourselves. The link here below, Logz.io/free trial. And with that, I'd like to thank all our audience, and maybe we can take some questions from the audience. Charlie, back to you.
Yes, thank you, Dotan. Thank you, Vipin. Great presentations, great demos, really helpful. We got a couple questions that have rolled in throughout our time here, and so if you have any more, feel free to enter them. Now is the time in the question box. So first one is specifically about Lambda functions. So we work not with just containers, but also with Lambda functions. So how do you handle that? So I think this is one for Dotan about how we handle Lambda monitoring.
Yeah, so it's a great question. This webinar was clearly focused on containerized workloads, but many today already start mixing, containers with, let's say, higher level of abstraction with serverless. And I think AWS's Lambda is the most mature serverless solution out there. And the nice thing about it is that with Logz.io, you can monitor the Lambda, your code, your functions running inside the Lambda directly. We actually leverage the Lambda extensions. It's relatively new. It's an ability to have hooks within the life cycle of the Lambda and fetch the logs directly, your logs directly out of the function and ship them to Logz.io. So if you have serverless workloads running on Lambda, you have a very easy way of just shipping them directly to Logz.io. You don't even need to go through CloudWatch or any other service for that end.
Mm-hmm. Thanks, Dotan. Next one I think is for both Vipin and Dotan here. So it's about, DevOps is much about creating automation around operational flow. So how does Logz.io support this? I think this can be one for both Vipin and Dotan.
Vipin, you go ahead, take a first shot on that.
Yeah, so I can share in general about how we look at DevOps and monitoring and containers, and Dotan would love to hear the Logz.io specific view as well. So within AWS, the way we see customers who are adopting containers is that DevOps is kind of a mindset, as well as DevOps practices are a prerequisite for having a successful migration or a successful containerized application. And it's easier if you're doing it for like one application or maybe two applications, but as you scale, it becomes important to have a solid CI/CD pipeline so that any code that you have is tracked in some kind of version control. From a Kubernetes perspective, if you're using EKS or Kubernetes workloads, you want the ability to detect drift. So if the state of your pods or your overall cluster drifts away from its ideal or desired state, you need the ability to bring it back, and that's where GitOps practices come into picture. And along with all this, you need to have monitoring tied at every single step. The concept of DevSecOps is also becoming very popular among customers, because you want security to be ingrained into your overall development process, and it should not be an afterthought. So it should not be that you develop an application and then you send it off to the AppSec team or security team for analysis. So rather, you should have security ingrained into your overall DevOps pipeline and process. So from our perspective, DevOps and containers go hand in hand, and a lot of DevOps practices definitely help our customers be more successful with containers. And to add more color on the monitoring perspective, Dotan, I'll hand it over to you.
Yeah, I definitely agree with you, and I think automation is key when you don't talk about when you scale, as you said, to a large scale system. And this is why we put a lot of emphasis beyond the UI that you saw a bit of in the demo. We provide a very rich set of APIs that with which you can automate the task, and you can then take for example, you can create your accounts, you can fetch your alerts, you can automate all sorts of searches, so that in a way you can automate and integrate it as part of your CI/CD pipeline. It could be, I don't know, Terraform, it could be anything that you use to make sure that you can send, for example, you saw the deployment markers that you saw there that reported all sorts of CI/CD events, like deploying a new configuration to Kubernetes. You have an API that you can report these. So a very API-driven approach that enables those that take DevOps, just as the person asking this question. When you treat DevOps as automation, and I'm all in favor of that, I'm a strong believer in that, then you have all the API richness to perform the same operations also as API-driven and automated. So definitely, if you are looking for these sorts of methodology, and I encourage you to do that, then check out our API docs, and you'll find most of the things that you would want to do, and you can do on the UI and equivalent on the API side.
Thanks, Vipin. Thanks, Dotan. Next question here is about OpenTelemetry and Fargate. So the question is, I think this would be one for Vipin. would it be necessary to add OpenTelemetry to the task definition in a Fargate environment?
So OpenTelemetry is available for Fargate. So it was something that we had worked on during the announcement last year. And you would have to add it to your task definition file right now. We are working on improving that experience, but short answer is yes.
Got it. And the follow-up question to that one was, which network requirements are needed to send events to Logz.io? Would a NAT be enough? I think that's the one for, go ahead, Dotan, sorry.
I can take that. So essentially, Logz.io is a cloud service. Obviously, you need to have an access, a public access. If you work over VPC, you can set it up as well. But it won't, for those that need on-prem, isolated environments. Obviously, that would be more of an issue because it's not an on-prem installation. So, but as long as you're able to ship your telemetry, your logs, your metrics to our endpoint, then it should be fine. It's a public endpoint, obviously. So that's the constraint, if I understand the question. Vipin, if you have anything to add, feel free.
No, nothing specific, but just to touch upon the previous question, one about how you use it with Fargate. An easier way to do that is, you could use CloudFormation, and I'll put a link in the response to the question. So basically, if you use CloudFormation, that's much more easier for you to actually replace some paths so that you can actually say how OpenTelemetry should be pulling your traces from the Fargate workload.
Thanks, Vipin, for that clarification. The next question is around the differences between Logz.io Cloud SIEM and AWS services like GuardDuty or Detective.
Vipin, would you like to take that?
Why don't you start, Dotan, and I'll add in.
Sure. So I would say that in many senses they're complementary. On the Cloud SIEM, the idea is, again, the Cloud SIEM, I haven't talked too much about that, but it's a very good point. The Cloud SIEM is based similarly on Kibana and Elasticsearch. So in a way, it's a way to scan your logs and be able to fetch insights out of the logs in terms of the security analysis. But on top of that, you have a threat analysis. You can cross-reference that with lists of suspicious malicious IPs or URLs or similar, and you can do all sorts of enrichment, and obviously you can create classic dashboards that can help you monitor the system. So I would say that for DevOps practitioners that are already maybe let's say DevSecOps practitioners that has grown out of DevOps, that are familiar with the the elk stack mindset, developer mindset, DevOps mindset, and they find it easy to do that. And also in terms of scope of work, they don't need the full-blown heavyweight solutions, but rather take a lean and mean approach to their security DevSecOps practices. This is a very useful way, especially again if you already have the logs already there. So let's say that you have the operational logs there, and then you want to draw security insights out of your existing log. Instead of replicating the same telemetry data to another tool just to have a security related analytics, you have it in the same, as we said, the same data lake. Just look at it from the different prism, which is in this case the DevSecOps or the security related prism on the same data. So in a way, I look at DevSecOps as an extension to DevOps, and in terms of observability, the security is an extension of the operational pillars of observability. Still, data analytics, understanding and gaining insights out of your raw data, the telemetry data, to gain insights, in this case, about attacks, mitigations, potential risks, misconfigurations, and similar. Vipin, feel free to.
Yeah, I mean, I completely agree, Dotan. And to add to your point about complementary solutions, one thing I'd like to bring up is Security Hub. So AWS Security Hub is, gives you a very comprehensive view of a lot of security alerts and security posture of all of your AWS accounts. and it integrates with a bunch of third-party solutions. That's something that's been a key value proposition for Security Hub. And what Security Hubs allows you to do is, to gather data from different sources, and then you have like a one-stop shop to like actually figure out, how to continuously monitor your environment and also use automated security checks based on some AWS best practices and industry standards that your organization follows. So completely agree with Dotan's perspective on that.
Thanks, Vipin. Thanks, Dotan. We have one more question here, unless there's there are any others that get entered at the last minute here. I think it's more specifically for Dotan. Dotan, you briefly mentioned distributed tracing and how it can help your monitoring, but could you maybe take it one more level and just help us better understand how distributed tracing can help your monitoring?
Yeah, certainly. That's usually the question, because this is the youngest, I guess, type of telemetry out of all. But I think the importance of the distributed tracing is if you really run a distributed, highly distributed, microservice architecture, where the question of let's put it this way: if metrics tells you what happened and logs tells you why it happened, then traces tell you where it happened. And the where question becomes paramount when you talk about microservice architecture or very highly distributed system in general, because if suddenly you have an endpoint that is becoming slow all of a sudden, very high latency, and you want to understand where exactly the bottleneck resides, or if suddenly an endpoint stops responding altogether and you want to understand where the error is within a chain that may have, I don't know, a dozen of microservices involved, and maybe calls to third parties and databases, another one. The question of where things happened or where things broke, where things performed badly becomes paramount. And this is where distributed tracing helps. So with distributed tracing, the instrumentation itself provides the context of the calls. So from the very initial request coming into the system, you have the context propagated throughout your system from one service to the next, from one operation to the next. And then all of that is then sent to a backend tool, like, as I said, the Jaeger, but there are others like Zipkin open source and others, and obviously Logz.io, where you can then visualize, see the trace according to the request flow, and visualize it on a timeline, compare different requests, and make other analysis to get the full context of a single request from start to finish, and be able to pinpoint, here is the bottleneck, here is the critical path, here is the error within my request. So this is in essence what distributed tracing gives us.
All right, thank you, Dotan. I think that, one more question just popped in as I was about to wrap up here. Can Logz.io be used to gain raw insights and complement DevSecOps? Sorry, here, let me read this real quick before I. So there's a question about the integration between Cloud SIEM and SAST and DAST tools. So static application security testing and dynamic application security testing. I used to work at a SaaS and DAST company, so I can take this one if you guys are okay with it.
You're an expert.
Yeah, sure. So at least I used to do product marketing for static application security testing tool, and so I can tell you that the use case for hooking it up with the SIEM probably isn't one of the most common ones, right? Because the whole idea of static application security testing is that you're catching problems very early on in the software development lifecycle. So ideally in the IDE, but usually somewhere in the CI/CD pipeline. Whereas SIEM is usually, not always, but it is it's typically used more on the production monitoring side of things. So that's dynamic application security testing usually happens later on in the software development lifecycle. So that's where you might see more of those integrations. I can't speak to any specific integrations with Logz.io at the moment, but hey, one of the great things about our Cloud SIEM team at Logz.io is that we can turn around new parsers for new integrations very quickly. So would be something worth raising, through our support team within the app, or just by reaching out to us directly. But for static application security testing, it's not a use case we see quite as often. And with that, we're a minute over, and so I'll wrap things up here. Vipin, thanks so much for joining us. Dotan, thanks so much. That does it for today. So thanks everybody so much for joining, and we'll see you next time.
Thank you, everyone. Thanks for joining.
Thank you very much.